10.8, Day 2. Before we begin notes in this video, I would like for you to consider this scenario. Suppose you have 3 marbles in a bag, blue, purple, and a green. You randomly select a marble from the bag, put it back, and then select another. How many total possible combinations exist? If you said 9, you are correct. Since there are 3 marbles in the bag, there are 3 possible outcomes for pick number 1. And as long as you put that marble back, there are also 3 possible choices for pick number 2. To find the total possibilities, you would multiply those together, 3 times 3, which is 9 possible combinations. Second question I would like for you to consider is, how does this change if you do not replace the first marble before selecting the second? This will change the total number of possibilities for the second pick. So there's still 3 marbles for pick number 1, but there are only 2 possible marbles to pick in pick number 2. This means that there are only 6 possible combinations now. We have eliminated the possibility of picking 2 blues, 2 purples, or 2 greens since we are not putting the marbles back. These are 2 different types of compound probabilities that we are going to be discussing today. The first represents independent events. That is when the outcome of the first event does not affect the outcome of the second. For example, 2 events that are completely unrelated are independent, such as flipping a coin and rolling a die. There is no effect on one or the other because they are 2 completely separate events. Another example is if you're picking something with replacement, meaning if I pick that marble and then I put it back before I pick another one. Those are independent of one another because the choices remain the same for each pick since the first pick has been put back in the bag. Dependent events are when the outcome of the first event does affect the outcome of the second. These occur when you pick something without replacing it. So in that second scenario with the marbles, we pick the 1 marble, leave it out of the bag, and then the second pick is affected because there are no longer all 3 marbles in the bag. Make sure you wrote this down in your notes before moving on. So let's take a look at a few scenarios, and I want you to identify whether these are independent or dependent events. 2 die are rolled. A bag contains 5 yellow, 3 blue, and 12 green marbles. Austin chooses a marble from the bag, and it is not replaced. Allison chooses a marble. Joanna wants to read a new book. She randomly selects a book, puts it back on the shelf, and selects another book. Mr. Heller eats a chocolate chip cookie, decides one wasn't enough, and then eats 3 more. Now that we have a better understanding of independent versus dependent events, let's take a look at how we can calculate the compound probability of multiple events. First, you will find the probability of event A. Second, you will find the probability of event B. And third, you will multiply the 2 probabilities together. If you take a look on your notes, you will find this example. A bag contains 6 black, 8 blue, 4 yellow, and 2 green marbles. A marble is selected, replaced, and a second is selected. Find the probability that you would select a black marble and then a blue marble. First, we want to identify the probability that I would select a black marble. Since there are 20 marbles in the bag altogether, the probability of selecting a black marble is 6 out of 20. Second, if I put the first marble back in the bag and select again, the probability of selecting a blue marble the second time is 8 out of 20. To find the probability of doing one and then the other, I will multiply those two probabilities together. 6 out of 20 times 8 out of 20, which is 48 out of 400. Or, as we know, we should put these in simplest form, so we can also write this as 3 out of 25. This is a 12% chance. Let's take a look at how this changes when the first marble is not replaced. Our first probability remains the same because there are 20 marbles in the bag before I pick the first marble. However, if I pick a marble and do not replace it, I no longer have 20 marbles in the bag, rather I have 19 marbles in the bag. One thing to consider is that although the probability of selecting a black is 6 out of 20, I am not taking all 6 black marbles out of the bag. We are only selecting one marble at a time. We are also assuming that that one marble is a black marble. So we are assuming that all 8 blue marbles are still in the bag and that there is one less marble in the bag, making 19 total marbles. Finally, to find the probability of picking a black and then picking a blue, we would multiply those two probabilities together, which gives us a compound probability of 48 out of, this time, only 380 possibilities. This is a slightly greater probability, since when you take a marble out of the bag, it actually increases your chance of picking the color blue, especially if I've eliminated one of the black marbles. So this is 12 out of 95 in simplest form, or about a 12.6% chance if I write that as a percent. Remember to write any fractions in simplest form, and that you can also convert all probabilities to percents or decimals as well.